Just don't know when to share the screen.
So hi, for those of you who are going to be seeing this live, this is Saturday afternoon, and we're sat here with Uriel Kosiev from malwareanalysis.co, who unfortunately hasn't been able to make it to give his talk in person. So we've arranged to jump on this call with him and record his session for you, so you don't miss out on his exciting content. Over to you, Uriel.
Thank you very much, Chris. Thank you for presenting me. So hello, everyone. Thank you for joining this amazing conference. Didn't had the chance to get to Prague. Was kind of problem for me, but I'm really happy to be here and to conduct this presentation. And of course, this talk will be very practical. So before I'm actually starting my talks, I like to say that my talks are very practical, and I want to just to generally present to you what demos I will show you, so you have the interest in this presentation, in this talk. So basically, we have one demo about the dark side ransomware, where I will show how I learned from their couple of techniques, reverse engineer couple of techniques in order to implement them in my own malware as part of the red teams that I did. And the other demos will conduct it as a bypass techniques. I will implement 2 bypass techniques, and I'll show you actually how I get rid of more than 50% of detection rate. Okay, so basically the name of this presentation, I'll just share with you the screen. So basically the name of the talk is Malware Analysis, Red Team Edition, as you can see here. And basically the concept of this presentation and this talk is why red teams need to know malware analysis. Why a red teamer need to know how to conduct malware analysis, and not for the sake of malware analysis, like in the classic way, like for gathering indicators of compromise, IOCs, IOAs, understanding how the malware works in order to detect it, but for offensive purposes, for OffSec. Okay, so basically, we will start with what is malware analysis, what is red team, some misconceptions, and we will adjust ourselves into it. And basically, then I'll go into the practical examples. So let's get started, and I hope you have fun. So malware analysis, red team edition. Welcome, everyone. I want you to learn malware analysis. So why the heck you will want to learn malware analysis? As a red teamer in general, why do you need it? Or as a security engineer, why do you need to learn malware analysis? What it will give for you? What kind of knowledge, what kind of experience, what kind of understandings you will gain from it? So those are big and very important questions that I will try to give them answers for you. So first of all, a little bit about me, because I don't like to talk about myself too much. So my name is Uriel Kosaev, as I already told you, the book author of Antivirus Bypass Techniques, a book which presents you 10 different bypass techniques and how to implement them, talking about the concepts, the practicality in them, and also in the end of the book, some security recommendations followed by those bypass techniques. So I'm also the founder of Malware Analysis Co., where I conduct malware analysis, reverse engineering, and red teaming courses. So you can check it out there. Also, I have free content over there about malware analysis and other stuff, cheat sheets, blogs, people to follow in the community by Twitter and stuff like this. So basically, I'm also a malware researcher, YouTuber, blogger, lecturer. I was a red team tech leader in one of the biggest companies, beer companies in the world, and left there like a month ago, and proceeded. I basically decided to proceed to Malware Analysis Co. to do more of the courses, to contribute more to the community, and to teach more stuff about malware analysis and red teaming. So I have more time for this right now. So before the show begins, what's malware analysis? Like, I don't expect from everyone to understand what is malware analysis, and even though, let's do this in a very straight to the point manner. So malware analysis is the art of analyzing and research of malicious software, behavior, and patterns. Basically, a malware analyst or a researcher will take a malware, whether it's a PowerShell script, a bash script for Linux, or an P executable, DLL, or Excel or Word file combined with a macro code or whatever. This the job of the malware analyst will be to understand whether the file is benign or malicious, and if it's malicious, how it operates, what it does, what kind of goals it tries to achieve, the malware itself. The malware can be a dropper of another malware, it can be a ransomware, it can be an evasion module, a loader or injector, a lot of types of malware out there. So basically, to analyze malware is to understand how attacks are conducted. And most of the sophisticated attacks around the world today conducted by malware. They're not conducted by this guy who sits behind a C2 or whatever C2 it will be and runs comments. Yeah, of course, it happens. For example, in the Conti ransomware group, they have this tool they use, the operator tool they use for manual scanning and manual stuff. But eventually, their main goal will be to encrypt with the ransomware. Okay, so and this will be conducted automatically without a manual intervention. So this is basically a general explanation of malware analysis. In malware analysis, you have different types of levels. So the first level is called automated analysis. So it's whenever you take a malware, you drop it into an automated sandbox, which is basically based on a virtualized environment, virtual machine like EC2 in Amazon or Azure VM or VMware Workstation, VirtualBox, something like this. You have also implementations of automated analysis for free, like Cuckoo Sandbox, that you can use in order to automate your analysis. If you use websites like AnyRun, for example, and you drop your malware, it will execute the malware for you and it will extract information for you. So it's a great approach if you want to like extract in a fast manner. You want to extract an IOCs, like indicators of compromise, hashes, IP addresses, domain, stuff like this. It will be amazing, but it will have its limit, because if the malware has the ability of detecting the presence of a sandbox or a virtual machine, it will stop and it will do something else. It will try to evade the analysis of this automated sandbox. So it's great, but it has its limits. So the next level is called static analysis. When a malware analyst or a researcher um, goes into the file or the malware and tries to understand its building blocks, its code, its functionalities in its in the state before it's executed on your system. So basically, you're viewing the file. You can use tools like IDA Pro for disassembly, PEBear for PEView, basically when you want to view all the sections and the code sections and other imported functions. You can use a hex editor and you can use stuff like this for static analysis. In dynamic analysis, when you're actually executing the malware in a safe environment in your sandbox, or if you're a nuts, you basically execute it on a physical machine without any restrictions. So be careful with it. So in dynamic analysis, you basically take the malware, execute it on your machine. Of course, you pray that it will not break something, but you basically want to see how the malware reacts, how it behaves, what it does, what its goals. You want to, of course, monitor its behavior, its actions that made on the virtual machine or whatever you're running at. Uh, what kind of network connections it makes, what kind of attack techniques. It tries to evade antivirus or EDR software. It tries maybe to terminate some software like backup software. It tries to exfiltrate data. What it tries to do eventually. So you can use tools like Procmon for monitoring file events, registry events, and process creation, stuff like this. And you can monitor with Wireshark for network stuff, and all of this while the malware is running. So this is basically dynamic analysis. And of course, you have the top of the iceberg, which is called reverse engineering. Reverse engineering is where you go statically or dynamically into the malware and you actually dissect the inner concepts, the inner essence of the malware. You go into the malware itself, into the code, into the source, or should I say, into the disassembly or the compilation of the code. It very depends. Whenever you researching malware that is .NET C# compiled executable, you can throw it into dnspy, for example, and see the compiled code of this, and you will see the variable names and functions. Sometimes maybe not, because there is obfuscations applied to it. But whenever you take a C or C++ compiled executable, you need to disassemble it, and you will also only have the assembly code of it in either Pro, or maybe the decompilation or pseudo decompilation if you use either the compiler for such executables. So basically, you go into the inner essence of the malware. Okay, so it's basically like reading a code, like reading a book. Okay, so reading the code is like reading a book, because in any normal book, you have sections, you have the title, you have basically the content of this title, and basically it goes like this in malware analysis also. So we'll go into practicality in short time. So now that we understood generally what is malware analysis, what is red teaming? A lot of people will tell you a lot of stuff. What is red teaming? But let's just go with uh, um, understanding what is the real essence of red teaming and what is actually not. So red teaming is not about achieving a domain admin. So most or a lot of red teamers out there, they think, okay, so I got domain admin and that's it. This is the end goal. This is my career, getting domains admins. But red teaming is not really about getting a domain admin. It's about simulating real world threats. Let me ask you a question. Why, or do you think that most of the attackers are really give a damn about achieving a domain admin in your network? Most of the attackers today, they are about your data, whether it's encrypting your data, stealing your data, okay? And they only need a domain to achieve domain admin for as a means, as a necessary means to the end. So most or a lot of times, the attackers will not need your domain admin in order to get into your data. Most of the times, you can even encrypt the documents and desktop folders in your computer without having even a local admin. So basically, most of the time, attackers do not need the domain admin. If they go into achieving domain admin, they have a good reason for it. Okay, so what I'm trying to tell you here is not that domain admin is not good. It's an amazing achievement. You need to do it, but it's only part of the achievements. It's part of the targets. Because if you try to simulate, for example, a specific group, okay, like Conti or Lapsus or any other group, and this group specifically doesn't really go into achieving domain admin, so you're not really simulating them as a threat. Okay, so you need to understand your business, who targeting your business, whether it's your competitors or other threat groups. And by understanding who is your actual threat, you go and simulate those threats on your network, and you see how much your network is actually good up against those threats, whether it's through detections and firewalls and EDRs or whatever, monitoring. So now I want you to behold the power of red teaming. Cobalt Strike. Now don't take it seriously. It's just a joke. Cobalt Strike is an amazing tool, does a lot of amazing things, but it's not the essence of red teaming. A lot of time when you go and ask people what is red teaming for you, they'll say to you, yeah, it's like executing this tool, like Metasploit, Cobalt Strike, and now you have those new amazing frameworks like Havoc framework and all those open source C2 frameworks go out there. It's kind of popular right now, but it's not the real essence of red teaming. It's the tool, but it's not the goal of red teaming. It's not what defines a red teamer. But again, it's part of the tool arsenal, so we cannot deny it. So why not doing things like this? I believe that malware analysis and red teaming is love. Why do I think like this? Because think about it. If I'm as a red teamer, want to simulate real world threats of real threat actors, I need to know how they attacks and how they malware operates. So I need to have the ability of researching malware in order to understand those attacks. And as a red teamer, whenever I'm taking, for example, like a Cobalt Strike beacon, for example, as an executable implant, and I want to understand this implant, and I want to apply bypass techniques in order for in order for this to bypass any EDR and any antivirus, I need to understand how to analyze this implant and how to understand it from the perspective of the malware analyst. So when I have both of the worldviews of malware analysis from the blue team point, from the researcher point, from the analyst point, and I have also the offensive state of mind from the attacker's perspective, and I combine them, it's like yin and yang. It's an harmony, and it will give you, and it will basically advance you and make you much better and give you more understanding about how the operating system works, the internals, and how attackers are operating actually. So the power of malware and asset red teaming is a strong power. Now, don't get me wrong. Both malware analysis and red teaming are not about the tools one is using. I'm repeating this, the thing that I said before, but the ability to research and understand technical and abstract concepts. When you have those understandings and you combine them together, it's a real power. But mom always told us to stay away from bad guys. So sweet, but it's not the reality. In order to win the bad guys, you need to think and operate like the bad guys. It's a necessary thing to do as a red teamer and also as a malware analyst. If you're a blue teamer and you know how to think like an attacker, like a criminal, like a bad guy, it will basically give you an upper hand and it will give you big plus. You will know better how to hunt for attacks and not only to make those attacks and to operate those attacks. So basically, I can see blue team and red team, or like the same, or malware and asset red team as the same, is two sides from the same coin. This is basically what it is. This is how I see it. And I hope this is how you will see it. And you know what? Not only that, but the attackers understand it and they do it. And we'll see it in a minute. Cooperation is another key to success in order to become better red team and blue team. So it's as a side note, of course, it's very important to work together. If you have a threat intelligence unit and you can cooperate it with the red team, it will basically give you a real adversary simulation because the threat intelligence will give you the real feed or the most accurate feed about the real enemies or real attackers or adversaries that tries to infiltrate and attack your network. And if the red team can work together with the threat intelligence, they can more accurately go and simulate those attacks on your network, on your organization. And eventually, whenever the adversary simulation or the red team is done and you have a fully fledged report, you go with the blue team hand by hand and make the security better and the monitoring better. So whenever you have the cooperations between the teams, this is where real security comes into play. Otherwise, it's just a waste of time. So the big question, why malware analysts need to concern red teamers? I think you kind of already understood why, but let me emphasize it again. Because the bad guys do. This is the real thing. This is the real thing that I think a lot of people in this industry didn't really got this point, or most of the red teamers or the red team companies didn't get it. So I had this tweet like half a year ago, and I asked, "What do you think about malware analysis in red teams?" And I can say to you that 99% agreed with it. So people know about it, but I want for more people to know about it. to understand it. So threat actors evolve by learning and leveraging the craft and TTPs by researching malware samples in the wild. So why red teamers cannot do so? Why the bad guys go and learn from other malware, from other adversaries, and red teamers don't do it? Why? Why the bad guys can do it and the red teamers not? Think about it for a second. Contemplate about it. Like if one threat actor, like Logbit, for example, can learn code and or take snippets of code from an existing malware like dark side ransomware, why not doing it? And they actually did. And the code that I will present you in the first practical demo about the dark side ransomware, you will basically see that if you go and research Logbit 3 ransomware, part of the codes are the same. I have actually made a video about it in my YouTube channel, so you can also visit and see it. So after we understood that attackers actually go and learn from each other's malware, and that red teamers also need to do it, let's understand about the malware development lifecycle. So it's something very generic about how to develop malware. So one of the reasons for a red teamer to learn malware analysis, not only to understand other malware, it's basically to take not only the code, but the techniques and the tactics implemented in those malware and to re-implement them in your own malware, in your own red teams. So I propose to you the malware development lifecycle, MDLC. It's like the SDLC, software development lifecycle, but for malware, which is kind of the same. So you go into malware development, you develop your malware, you define, you do the project plan, everything like any other development project. Of course, you're testing it and do the quality assurance you need to do on the code. Yeah, and a lot of malware out there has like a very fatal vulnerabilities that you can exploit. And actually, one of the blogs I made on Ardam Excalibur, we found their DLL hijacking vulnerability. It's kind of funny. And afterwards, we actually noticed, me and my friend Nir, we noticed that actually there was like there is other researchers in the industry that actually go and do vulnerability research on malware. So it's kind of funny, but yeah, we have this concept. So write your malware in an OPSEC manner. Write it in a secure manner, because whenever you use malware on your client with the client's of consent, of course, in a white hat manner, and you do it on an organizational network, especially if it's a big network, you want for your malware to be secure and for your malware not to create backdoors and stuff like this. So you need to be very careful and really understand what your malware does. So of course, after you do the testing QA, you need to implement some malware defense bypass. So if you need to evade some EDR or bypass some antivirus, you need to do it as part of your code or part of a loader or a downloader malware or whatever. It very depends on the project and on the goals. Then you do offline antivirus and EDR testing. So basically, you take the antivirus agent and you test your malware against it, because you want to really make sure before you go and attack your network, basically, or trying to achieve your goal. Beforehand, you want to test your malware against those antivirus or EDRs. Then you go into IOC collection and removal. Basically, this whenever you do the offline AV-EDR test, you go and understand whether the EDR or antivirus detects your malware. And if it detects the malware, you need to understand how it detects and why and what it detects in your malware, whether it's a string or an IP address or something in the behavior itself or the function or the Windows API functions used, for example. So if you can do IOC removal or removal of any other indications, for example, encrypting your payload, obfuscating it, packing it, using some dynamic engine bypass techniques like time-based attacks, okay, like memory bombing that I will present to you, then you can basically bypass this EDR. And of course, you go into in testing again and again and again. And of course, if you have a threat intelligence team in your organization, you want to basically share the data with them. So you have some threat intelligence feed and you want to share this with them so you can cooperate and make detections better. So you do not have to develop your malware from zero. This is another thing that I want to tell you. Learn from real world malware samples and incidents. Learn from their techniques, learn from their code, and try to re-implement them in your own malware. You don't really need to have the exact same code and exact same variable names and functions and whatever, but get the concept of those malware, the concept of those techniques, implement on those malware, and try to re-implement it in your own. So we got into the demo part. So the first demo is about dark side ransomware. And I want to demonstrate to you two techniques. The first is called runtime code decryption, and the second called dynamic API import or dynamic API resolve. So basically, we will see what it does in a second. So whenever you go from the view of the malware analyst or a red teamer that understands the power of malware analysis, you will see that there are no functions in the IAT, in the import address table. Each executable or P executable, basically, whether it's exe or DLL, has what's called an IAT, import address table, which is basically a table which includes the reference for all the functions or the imported Windows API functions that will be used in runtime, in execution, by the malware or by the executable. Okay, for example, if I have a legitimate calculator, I need to have a functional that displays a window. So like function like create window will be used. Or if I have a malware that needs to communicate with an external server, I can use the Windows API function. So internet open URL or a simple socket or whatever in order to interact with a remote server. So there's no functions in the IAT, in the import address table. If you go and put the malware inside, in this case, I use the amazing tool of HasherZ. Basically, it's called PEBear, also presented in my book, Antivirus Bypass Techniques. Amazing tool. Basically, whenever you put this malware inside PEBear, like in most cases, in most malware or even legitimate files, you see more than one DLLs. You will see something like 3 or 4 or 5 DLLs and a lot of more functions. And here you can only see one DLL is imported, current 32 DLL, with only one function, exit process. It's like what the hell moment? Like why there is only one function? So the only goal, the only thing that the malware or this whatever file does is to exit the process. So something is really fishy about this sample. So whenever you try to whenever you see something like this, one of the things you can think about is that some packing or encryption was implemented while basically written by the malware authors. And whenever the malware is executed on your system, it will unpack or decrypt itself in runtime. So if I put the malware into IDA Pro, you will see this is the functions or the assembly code, basically, after the disassembly was made by IDA Pro. This is the actual code of this malware. This is the entry point of the code. So you have basically two blobs that are loaded from the resource section, okay? And then basically this is encrypted data. Then the encrypted data is unpacked and decrypted. And then basically it will be moved into the location or the memory location where the call for this function, I named it basically where hell begins, because this is actually where all of the operation of the malware actually begins. Okay, so you can see here that the text one section, which is another weird indicator because most of regular malware will have the text section, or regular files will have text section, but not text one or text two. Of course, you can rename the sections, but it's not something regular and normal. So you can see the text section is actually encrypted, okay, which is the same location where the blob or where um, all of those operations will be made, or where the memory location of the where help begins will begin actually. And the text section and the text one section, as you can see here, is the unpacking step or the decryption step. So basically the goal of the text of the code that resides in the text one section is to unpack the code from the resource section and to move it to the text section, and from there the execution will begin. I know it's kind of not straight to the point, but this is malware analysis, this is research. So this is how the runtime unpacking and decryption is made. So basically it will go and load the data from the resource section. It will take the data to be XORed, and then it will do some, I would call it mumbo jumbo stuff because we have a very short time. And it will basically do a XOR decryption. Very simple one. It will take 256 bytes and will dexor the file. So basically it will do XOR with the AL on EDI, and basically it will move the basically the decrypted data into the destination text section, basically. And we have another technique called dynamic API import, which is used to bypass mostly static engines because it will hide functions that the static engine of the antivirus or of the EDR will try to catch or to detect. So here it will basically go in order to for the malware like to automatically or dynamically resolve the used Windows API functions in runtime. It will go and resolve those functions in runtime. So remember the file that we saw on PEBER, there was none any other functions, only the exit process function. So now in this stage, it will decrypt and unpack, basically resolve and import all of those functions for the usage of the dark side ransomware. So specifically here, they will use load library to load the DLL file and get procedure address or get proc address to get the specific function or functions from the DLL that is loaded. So this is a very classic dynamic API resolve or you can call it API hashing technique in order to bypass static engines, and it actually worked for them. They encrypted the Colonial Pipelines network, which is basically something like I think, don't catch me on the word on the numbers, but something like 50%, I think, from the United States oil gas station. So gas stations were locked, and it was real havoc. So after the decryption is made and the API resolve is made, you can see the runtime built for you. So the IAT is built for you dynamically. So now, after all of those mumbo jumbo operations has been made, you can see all of those functions available for use for the malware itself, for the dark side ransomware. Okay. So as I already mentioned, this technique is implemented also in the Logbit ransomware, and you can see the video that I made in my YouTube channel. So this is basically this. So now you can try to digest all of this information and think, okay, so why me as a red teamer, what actually need to concern me? Because understand something. If you have, for example, an EDR that you need to bypass or an antivirus, and you try to think what type of bypass techniques is right for bypassing the static engine in the antivirus or the EDR and the dynamic engine. And also you have the heuristic engine and a lot of other engines, but how I bypass it. And for me to learn bypass techniques was not only from like playing with stuff and do experiments, is like from, of course, reading blogs and stuff like this, but also analyzing and researching malware samples and learning from them. And it is an amazing experience because you can see actual malware, real world stuff, real world bypass, and it's only getting and evolving every time and every time. So as a red teamer, you can go and learn from malware samples such as DarkSide and others, and re-implement techniques that appeals to you and you can use as part of your red team operations. So let's talk about two more bypass techniques. and uh, proceed from there to some recommendations. So we will talk about random obfuscation and memory bombing. Those are two techniques presented in my book, Antivirus Bypass Techniques, and I will present it to you here right now. So let's take a simple reverse shell. We have a simple reverse shell, which defined with the callback IP address and the port that needs to communicate with. As you can see here, it takes two arguments and basically passes them to the execute shell function. Now, as you can see, execute shell is a very problematic name because whenever you see the name or the string shell, it can be an IOC, an indicator of compromise, potentially for antivirus or EDR. Very depends on the detection logic and other stuff, but yeah. And here is the function itself, takes two arguments, the C2 server, C2 port, and again, the C2 naming convention here, the C2 thing is very problematic for bypass. It can be very easily with a simple regular expression, implementing detection logics of the vendor, it can be detected. So it opens a socket, creates it, takes the arguments, and basically do the socket magic. So now for me as an attacker or as a red teamer who has the ability to analyze my own malware as a malware analyst, okay, I will compile this malware to an executable, and then I'll search for problematic strings. So here, just for the example, I execute the strings command on the executable and did a in case sensitive search on a word called CMD. So basically CMD with something. And a lot of times in malware, whenever you see CMD something, it can tell you that it tries to execute some commands on your machine. So it can be another indicator for malicious or for suspicious activity. Okay, so me as a red teamer, I understand it. Okay, so fine. Now I'll go and try to hide it somehow. So there is a technique that's called rename obfuscation. This is the name that we gave in our book, me and Nir. So basically, as you can see here, I renamed the function of execute shell to run. And again, it doesn't really need to concern me as a red teamer what is the name of the function as I'm writing this code, but I need the thing that need to concern me is how my malware, the compiled malware version, for example, will be viewed by analysts, by researchers, and also by antivirus and EDR products. So I managed to basically change it to run. And then I did a simple trick here. As you can see, before it was like CMD exe in one char variable, and then I split it to two char variables, cmnd.exe, as you can see here. And then I define another pointer variable called p, and concatenated both of those variables. So now we have cmd.exe, but in a slight different way. And then I pass this p variable with the concatenated version of cmd.exe, which does the create process and actually spawns cmd.exe for the socket, for the reverse shell itself. So in that way, I go and validate again the IOC removal after I've compiled again the executable after the change I made. And voila, you see that cmd dot something is gone. As a side note, you see that it was like cmd dot something. It doesn't have the cmd dot exe because C++ has a very weird uh, way of working in that way that it will go and do \n on stuff, and you'll see, for example, an IP address like 192.168.1.1. You'll see 192.168 in the compiled version, and then you'll see a new line .1.1. This is the this is the weird ways of how C++ works, and basically I managed eventually to get rid of this IOC in some way. Of course, if someone understands how the compiler works, it can give a great perspective on an expectation of how the malware or the executable will be compiled and will be in the executable form of it. And in that way, it will be easier for you to understand how to get rid of those indicators. So the second technique is called memory bombing, which basically is used for bypassing the dynamic engine of the antivirus or the EDR. It's a very simple technique, again, presented in my book, Antivirus Bypass Techniques. It's a very simple technique. I'm just allocating a very large memory portion for the antivirus or EDR to not basically uh, scan this file, because basically I'm trying here to buy some time in order for the antivirus or the EDR to not detect me. Because whenever a dynamic engine wants to uh, scan my malware, whenever it's executed, it goes and basically allocates some free memory in the RAM or in your computer, basically, and emulate this behavior, the malware itself, in this safe allocated memory. So if I allocate enough memory, enough big memory in my own malware, it will basically take more time for the antivirus or EDR to analyze my malware, and the EDR will prefer to let me go, to let my malware execute on my machine, because the EDR or antivirus is limited to the same resources allocated in the same operating system. So it has a very limited time and very limited resources to research or to basically scan my malware. I know it's kind of like it's a very simple technique, but with a lot of understanding and wisdom behind it. Because if you understand how something works, you can go around it. Okay, so in the understanding of how EDR and antivirus works in this case, the fact that EDR and antivirus has a very limited time and resources in order to scan malware or whatever files or processes, I I actually go and exploit this fact. Yeah, this is the truth. Okay, so after I've implemented both of those kind of simple techniques, let's see the test results. So before rename obfuscation memory bombing was applied, there was 35 detections, which is fine. It's amazing. I expected even more because it's a very simple reversal, but again, it's fine. 35 detection out of 71. A great detection rate. But after we did the rename obfuscation and the implementation of memory bombing, we get half down, like more than 50%. It's like something like 50%. It's like now we have only 13 detections, and a lot of other antivirus and EDRs are not detecting it. Now, in most cases, if you're doing an red teaming operation on and you know that you have a specific product like a specific EDR or a specific antivirus vendor, you will want to only bypass those products. But if you want to create something that is FUD or fully undetectable, which is very, it's not, I can't say it's hard to achieve and it's not easy to achieve. It very depends on what you're writing, the code that you're writing, and the goal that you're trying to achieve. And again, it's not black and white. There's a lot of grays in our life, like in between stuff. So take this in mind. So in this case of reversal, I got 13 detection, which is amazing. Now think about it. If I were to implement one or even more two techniques in the same sample, most likely I will get 0 detections, fully undetectable. So again, it really depends, and it really depends on your experience and the way you're coding your malware, and of course it depends also on the EDR and antivirus side that tries to detect your malware. So let's do let's give you some tips for how to become a better red teamer. First of all, always understand your tools and malware. Go and research your own tools, like literally how they work, how they operate, how they communicate in the network level, how they communicate with your operating system, how they execute it. And you will be surprised what you will learn. Get as deep as possible, because again, you will be surprised what you will learn. Because if you go and only execute such and that tools, and you don't really understand how they operate, how they work, you will have a very limited understanding of things. Learn malware analysis to understand and think like a blue teamer. Because as a red teamer, if you know how to think as a blue teamer, and also it's basically true for the opposite. If you as a blue teamer know how to think as a red teamer, you have the benefits of, what I call it the transcended thinking. You will think differently. You will see. Don't take my words. Don't like believe my words. Go and try for yourself. Go and experience stuff. Research malware to gain deeper knowledge and inspirations. Like get more ideas of what you can do in your next red team, in your next attack, in your next tests. Follow the MDLC model. Malware development is like any other SDLC process. You need to write your malware, especially as a white hat hacker, you need to do it responsibly. You need to write your code in a fashionably manner, in a secure manner, and do QA tests. And if you need to implement bypass techniques, you need to also do it without, breaking stuff. And it's very hard, but professionalism is number one. Actually, to be a human being, to be a good, decent human being is number one, and professionalism is number two. Always remember that. Be curious, passionate, and innovative. Always try to push stuff, to be curious, to learn things. Be passionate. Don't be a jerk. Don't be a zombie. Do your thing with your heart, not only with your mind. Mind and heart together. And of course, take some breaks, man, because or a woman, like take some break because I know a lot of people in this industry, they go and work and write code, write tools, go and doing blogs and doing videos. Like there's like an amazing videos out there, amazing YouTube channels, amazing contributions. This industry is amazing. The people are amazing and the content is amazing. But man, get some break, man. Get some break. Don't give your soul the time to reinforce itself, and you will see that when you go back into the daily cycle stuff that you're doing with Marmanas and writing and everything else that you're doing, writing blogs and whatever, you will do it better because you gave your soul rest, basically. Um, yeah, so this is part of the tips. And again, think like fluid water and not like a rigid rock. Okay, always be open for new ideas. Think and operate like a criminal, because if you don't know how to be a criminal and how to think like the bad guy, so you will not be it. Help security grow and become better in this way, in understanding the opposite side, in understanding as a red teamer, in understanding the malware side and the malware analysis side, or the blue team side, understanding the red teaming side, basically to become better and stronger. So if you want to visit my website for courses, for my course or other free resources that are available there, you can visit Malware Analysis Co. And of course, feel free to contact me in LinkedIn or Twitter. I'm available for you. So yeah, basically, thank you very much. If you have any questions, I'm here for you.
Thank you very much, Oriel. That's a great talk. Great material. Thanks for making time to make the recording for us. One question that did crop up for us as we were going through in your malware development lifecycle, you were talking about testing against EDR. So if you know a particular target is using, product X, how do you go about testing against that particular EDR? AV you can download from anywhere and install. EDRs a little
Yeah,
more
I know.
sketchy.
I know. If you're like a white hat red teamer and in your own in the same organization that you work in, you have a specific EDR like CrowdStrike or Sentinel-1 or other product, you will basically can ask the blue team to give you a license or basically an agent to test it. So if you're a part of the same organization, it's very easy. But if you're an external red team operator and you don't really know about the organization, it will be much harder. And if you don't have access to such EDR, so yeah, we basically need to go into the network and try to do your best. And yeah, it's very limited.
You're saying test in production. We like that.
Yeah.
Cool.
Take the EDR or understand the environment and try to do your best from there.
Excellent. Cool. Thank you very much. I think that's about all we've got time for in our slots today. If there are any questions that crop up on Saturday, I'll ping them over to you, and if you'd be so kind as to ping me back, I'll get the answers to those guys.
For
Cool.
sure.
Thank you very much.
Thank you very much, Chris. Happy we made it, and let me know about if you want me to share stuff, and the recording itself. I will also upload it to my own YouTube channel. It will be amazing.
Will do. Thank you.
I'll be happy to do more talks of that like this.